Okay, okay. Well, ladies and gentlemen, please welcome to this interesting live tonight, where we mix physics and neuroscience. So, uh, tonight, the FreeAstroScience channel, we is very grateful and very proud host a researcher which which make a very interesting lecture. But let's leave the word to our Vice President Flavia. Flavia, your time.
Thank you very much. Hello, everyone from around the world. I'm Flavia. I'm from FreeAstroScience team. And tonight in Brazil and Italy, but can be the morning in your country or afternoon, we have a very special guest. His name is Adriel Weber. He is Brazilian. He's a physicist. And I will say something about him, about his profile. Adriel is a psychoanalyst, writer, researcher, and speaker with a degree in physics from Unicinos and MBAs in project management and human resources management. He holds a master's degree in neuropsychology and is currently pursuing a doctorate in neuroscience. He is the manager and scientific research advisor at CEPA, Centro de Pesquisas e Análises Heráclito, where he works on projects such as gifted debate, neurogenomic, RGTEA, among others. A member of Mensa International and CEPA, he also serves as the Brazil coordinator for the Infinity International Society. He delivers seminars and participates in research groups. He is twice exceptional, being both gifted and autistic, and is the author of books that explore neurodiversity and child development. Adriel, the floor is yours.
Thank you, Flavia. Thank you, Gerd, for your time and for having me here. So in order to start, I'm going to share my presentation here. I'll just need a second, please. Here in the presentation. Okay. Okay, share. So just let me know when you can share my screen, when you can see my screen.
Yes, we can see.
Yes, we can see.
Perfect, perfect. Okay, let me just adjust here. Yes, when you work with 3 screens, it's a little bit complicated to organize things, right? Okay, let's go. Great. So once again, thank you for having me here. And we are going to talk about this topic that is very interesting from my point of view. So in this seminar, I'd like to explore a very bold question. So could quantum physics lie at the heart of our conscious experience? So this is a good question, right? We will focus on the Orch-OR theory, short for orchestrated objective reduction, and use it as a lens to connect physics and the mind. So over the next minutes, I will briefly review the standard theories of consciousness, explain what makes Orch-OR different, and look at recent developments and experimental ideas. As you listen, try to keep one question in mind. So, if consciousness really is tied to the deepest structure of the universe, what will that mean for how we understand ourselves? Let's move to the next slide here. Okay, so let's start with what we mean by consciousness. I'm not talking about brain activity in general, but about what it feels like to be you. So, for example, the taste of the coffee, the redness of red, the feeling of pain or joy. So, this is what philosophers call the hard problem, you know. Why should physical processes in the brain produce any inner experience instead of just being unconscious computation? That's a good question too. So the classical neuroscience is very good at telling us which brain areas light up when you see a face or move your hand, but it does not explain why there is something in it. It is like to see or to move. So similarly, early computational models can simulate behavior, for example, yet they struggle to explain subjective qualities and the unified all at once character of awareness. So the quantum mechanics enters the scene because it brings in ideas like superposition and entanglement and non-locality. So these phenomena that are intrinsically holistic and probabilistic. So the central question for this talk is, can these physical principles help us understand how subjective experience submerge from matter? In other words, could the physics underlying your phone or your magnetic resonance imaging scanner also underlie the feeling of being you, for example? Let's move on. Right. So before narrowing in on the Orch-OR, it's useful to see the broader landscape of consciousness theories. So one influential view, the global workspace theory says a mental state becomes conscious when information is broadcast widely across the brain's networks. So a bit like data appearing on a shared screen that many areas can access at once. And another framework, integrated information theory, proposed that consciousness corresponds to the amount and structure of integrated information in a system, symbolized by the Greek letter phi, for example. So, on this view, anything with sufficient height phi from our brain to a complex chip, for example, has some degree of experience. And higher ordered theories add a different twist, for example. A thought of perception becomes conscious when the brain has a higher order representation of it, essentially when the mind thinks about its own matters or its own states. All of these approaches are largely classical and computational, so they assume neurons behave like very sophisticated transistors, for example. And in contrast, the quantum mind theories, and the Orch-OR in particular, claim that consciousness depends on fundamentally quantum processes inside neurons. So we are not just talking about a faster or more complex computation. We are asking whether a different level of physics is really required here. Now let me introduce you the Orch-OR itself. The theory was developed in the 90s by Sir Roger Penrose, a mathematical physicist, and Stuart Hameroff. That is, he's an anesthesiologist, and Penrose argued, based on mathematical reasoning about Gödel's theorems, that human understanding cannot be fully captured by standard algorithms. suggesting that some non-computable physical process must be involved in consciousness. So independently, Hameroff studied the fine structure of neurons and became fascinated by microtubules that are tiny protein cylinders inside the cells, inside the neurons. When they combined their ideas, they proposed two key claims. The first one is that quantum superpositions can form inside these microtubules, so that many alternative states of neural activities and can coexist briefly, rather than the brain being in a single or definite state. And the second, that these superpositions collapse through a specific physical process called objective reduction, or the OR, rooted in quantum gravity, for example. According to the Orch-OR, this theory, each such collapse is not just a physical event, but a discrete moment of conscious experience. And the brain's biology orchestrates these events into the flow of awareness we live through from instant to instant. So this is a very interesting concept. To see how this might work in the brain, we need to look more closely at microtubules. So these are hollow cylinders built from repeating units called tubulin dimers, and they form part of the internal skeleton of the neurons. So these help maintain the shape and transport materials inside the neurons. And Sir Hameroff proposed that tubulins are doing much more than structural work. So each tubulin can adopt at least two conformations, which is principle could function like a quantum bit or Ku bit. If many thousands of millions of these tubulins are in quantum superposition together, a neuron isn't just on or off, for example. It exists in a rich cloud of possible states. And a key challenge is the coherence. So in warm and wet environments like our brain, the quantum states usually fall apart very quickly. And the Orch-OR responds by suggesting that the ordered water inside microtubule cores and the specific geometry of proteins might help shield these states, somewhat like insulation around delicate electronics. Interestingly, all general anesthetics, despite their chemical differences, bind to places on tubulin. And when they do, the consciousness disappears. So this is very interesting. That's an everyday observation from medicine that Orch-OR interprets as an indirect hint. Interfering with microtubules may switch off the quantum processes that support experience. In the same way, pulling the plug off a TV, even though the screen itself is still intact. And also, the Penrose's idea of the objective reduction, or the OR, is the second half of the story. In the standard quantum mechanics, a system can be in superposition, so many possible states at once, until a measurement causes the wave function to collapse randomly into one outcome. So Sir Penrose suggests this is not the full picture. So he proposes that superpositions create tiny unstable separations in the geometry of space-time itself, and that beyond a certain threshold of energy and duration, the nature cannot sustain this. At a precise mathematically definable moment, the superposition undergoes an objective non-random reduction to a single state. And the Orch-OR claims that in the brain, the quantum superpositions in microtubules build up until they reach that threshold. So this resulting the OR event in a primitive moment of awareness. And the orchestrated part refers to how biology, the synaptic inputs or the microtubule associated proteins and network dynamics tunes which superpositions form and when they collapse. In everyday terms, it's as if the brain sets up a complex question in quantum form, and the universe itself sets up a complex question, as I mentioned, and through the structure of the space-time. So selects an answer which appears to us as a tiny flash of a conscious experience. And what kind of evidence do we have in this case? And where is the research going? So first, we know that quantum effects can operate in warm biological systems. For example, in photosynthesis, for example, experiments have shown that energy seems to move through plant proteins via quantum coherence, taking multiple paths at once to find the most efficient route. So certain birds, for example, appear to use entangled molecules in their eyes as compasses to sense Earth magnetic field. So these findings don't prove the Orch-OR, but they break the old assumption that life is too warm and noisy for quantum physics to matter. And second, the anesthetic drugs, again, provide a suggestive clue. They all disrupt consciousness, and they all bind to tubulin or nearby hydrophobic pockets, which fits the idea that they are interrupting quantum processes in microtubules. There's also a link between 40 hertz gamma oscillations in the brain and conscious states. Updated Orch-OR models in 2010 argue that orchestrated collapse events could align with these rhythms. On the experimental front, for example, technologies like high resolution cryo electron microscopy are revealing microtubule structures in unprecedented details. And researchers are developing ultra sensitive quantum probes and diamond based sensors that might, in the near future, detect subtle vibrations or coherence inside living neurons. There are even speculative tests involving near death experiences, and Hameroff has suggested that quantum information in microtubules might persist briefly after cardiac arrest, which could, in principle, be probed by studying patients resuscitated after any clinical death, for example. Of course, the Orch-OR remains controversial, and it's important to look at the criticisms clearly. One major objection comes from the coherence calculations by Max Tegmark and others scientists, which suggest that quantum states in the brain should fall apart in about 10 trillionth of a second, and far too quickly to influence millisecond scale neural firing. So on this view, the brain is simply too hot and wet to host any stable quantum computation. And supporters of the Orch-OR respond with revised calculations and point to ordered structures and cavity-like regions in microtubules that might medically extend coherence times. But this is still actively debated by the scientists. And a second criticism is that we still don't have direct experimental evidence of microtubule superpositions in living neurons. So this is difficult for us to prove that. We only have circumstantial clues, and in vitro results. And third, even if microtubules did undergo objective reduction, skeptics will ask, so why should that be accompanied by subjective experience rather than just being another physical event? So this is the same explanatory gap that affects many theories of consciousness. And finally, Penrose's argument that human understanding goes beyond algorithms based on Gödel's theorems and is widely challenged. Many philosophers and computer scientists think it doesn't prove what he believes it does. So while the Orch-OR is imaginative and mathematically detailed, it currently sits at the edge of the mainstream science. And despite these challenges, the Orch-OR has helped open a valuable research space where the quantum physics, biology, and neuroscience met. And the 2014 revision of the theory and later updates uh, have tried to address earlier objections by focusing on the experimentally accessible predictions. For instance, that microtubules should exhibit specific quantized vibrational models in the megahertz to gigahertz, megahertz to gigahertz range, and that this vibration should couple to EEG rhythms associated with consciousness. So recent work in quantum biology has found more examples of structured coherence in proteins and in ion channels, which some researchers interpret as indirect support for the idea that brain might harness quantum effects. The development of nanoscale sensors, such as nitrogen vacancy centers in diamond, that can detect tiny magnetic fields. So this raises the realistic possibility that within the next decade, for example, or we may be able to test whether microtubules inside living neurons show the predicted quantum signatures. And from a broader perspective, the real contribution of Orch-OR may be methodological, and it pushes us to design concrete experiences rather than only philosophical arguments about whether consciousness taps into non-classical physics. So to wrap up, let's step back and see the bigger picture. So we started with the hard problem. So the classical neuroscience can explain a great deal about information processing, but it does not yet explain why that processing should feel like anything from the inside. The Orch-OR offers a radial hypothesis that the quantum superposition in microtubules terminating in objective reduction events are the basic units of conscious experience, orchestrated, of course, by the brain's biology into the stream of awareness you and I live through. And along the way, we saw that there is some suggestive biological evidence and emerging toolbox of quantum level measurements, but also substantial theoretical and empirical challenges, especially around the coherence and the link between physical events and subjective qualia. The open questions are really profound. So, for example, can quantum coherence in neurons really last long enough to matter? So, or is consciousness an emergent property of complex information processing? or does it reflect something more fundamental about space-time itself? So upcoming experiments from microtubule spectroscopy to in vivo quantum sensing may not only confirm or refuse the Orch-OR, they may force us to revive and to revise what we mean by mind and matter. As Niels Bohr warned us, so quantum mechanics is deeply shocking, and whether or not the Orch-OR turns out to be correct, the attempt to build a physics of consciousness is likely to change how we understand the reality and our place within it. So this is what I have to bring here for you guys, and I'm open for the questions, Flavia.
Oh, that's amazing,
Oh,
your
very good.
presentation. Oh, thank you very much, Adriel. It was fantastic in the state of the art of physics nowadays. So I will ask my first question. I'm very curious, and I hope you can
Mhm.
satisfy my curiosity with your answer. The first one is OR theory proposed that consciousness emerges from quantum processes within neuronal microtubules. Considering the criticism regarding thermal decoherence in the brain, what are currently the most promising experiments to validate or refute this hypothesis?
Yes, that's a very good question. And the big criticism against the Orch-OR is that the brain is too warm and noisy for delicate quantum effects to survive, like trying to keep an ice cube solid in boiling water, for example. This is a comparison that we can do. So the key question is, can microtubules in neurons actually maintain quantum coherence long enough to matter for consciousness? So right now, the most promising experiments go in a few directions. So the first one is people are studying microtubules and tubulin in vitro using techniques like terahertz spectroscopy and ultrafast lasers to see if they show coherent vibrational modes at room temperature, for example. Some experiments do show organized wave-like vibrations in microtubules, and the big open question is whether these are truly quantum coherent or just classical vibrations. So we have to have this differentiation. And the second, some other researchers are looking at how anesthetics affects microtubules. And since anesthetics reliably turn off the consciousness in everyday medical practice, and many of them bind to the tubulin. So the scientists are measuring whether anesthetics change the vibrational or electrical properties of these microtubules. So if we eventually see that anesthetics specifically disrupt genuine quantum coherence in these microtubules in a way that tracks exactly when consciousness disappears and returns, that would be strong evidence in favor of the Orch-OR. So we are not there yet, but that's the direction. And the third one is that there is the broader field of quantum biology. We already know that some biological systems like photosynthetic complexes in plants and bacteria use quantum coherence to transfer energy efficiently at normal temperatures. So, as I mentioned before, that doesn't prove the Orch-OR, but it does undercut the old argument that biology can't use quantum effects because it's too warm and noisy and messy. And finally, there are highly sensitive attempts to pick up the quantum signatures in or near neurons using tools like NV centers and diamond or quantum dots. So these are still very early and technically brutal, but if they even detect sustained quantum coherence tied to neural activity, that would be a huge deal. So in simple terms, people are building better microphones to listen for very faint quantum whispers in microtubules and neurons. So if those whispers are real and functionally linked to consciousness, the Orch-OR against serial support, and if not, it's in trouble. Yeah.
Oh, Adriel, the more you talk, the more my curiosity increases. So
That's
let's
good.
move
That's
to
good.
the
That's
second
excellent.
question. If consciousness depends on non-computable quantum processes, as suggested by Penrose, would this imply fundamental limits for artificial intelligence in reproducing human consciousness?
Yeah. Penrose's idea is that part of what the brain does, specifically in consciousness, is not just very complicated computation, but literally non-computable. So there is no algorithm, no matter how clever, could fully capture it. He links this to special kinds of quantum state collapsed in the brain. So if Melrose is right, then any AI running on classical computer, like our current systems, including large language model, would be forever limited. So it could be imitate conscious behavior and talk about feelings, self, introspection, but it would never have the real thing, the genuine conscious experience, because it just doesn't have access to that non-computable physical process. So even quantum computers might not solve this. And a quantum computer still runs algorithms. It's just using quantum hardware. If the crucial step is in consciousness is fundamentally non-computable, as per Rawls' claim, then even a perfect quantum computer wouldn't truly replicate it. On the other hand, most scientists don't buy Penrose's argument, so they tend to assume that whatever the brain does is still physically lawful, and therefore, in principle, simulable. So just maybe insanely complex, you know. So under that more mainstream view, there is no known fundamental barrier that stops AI from eventually being conscious. So the barrier is practical, resources, architecture, understanding, and not theoretical, in fact. So if I put it in one line, so if Penrose is right about non-computable quantum processes, then yes, there is a hard ceiling on what classical AI can ever be in terms of true consciousness. But that if is a huge and very controversial one. Basically, that's the I hope I have answered this question.
Oh, that's terrific, Adriel, and a relief for all of us. So, um,
Very nice,
moving.
very nice.
Yes, that's terrific, amazing. So I know that you talked a lot about anesthetics and the interruption of consciousness, but I would like you to detail more this topic, answering this third question for us.
Mhm.
The presentation mentions that anesthetics bind to tubulin and interrupt consciousness. To what extent can this be considered evidence for a quantum basis of the mind rather than merely a conventional biochemical effect?
Yeah, we know from everyday experience like surgery and dental procedures and ICU
Yes.
sedation that anesthetics can reliably switch off consciousness and then let it come back. So they do this by interacting with brain proteins. And some of those proteins are tubulin, the building block of microtubules. So the Orch-OR takes this and says maybe anesthetics work largely by disrupting quantum processes in microtubules, and that's why the consciousness disappears. For example, why you are under a sedation. So that is an interesting idea, but there is the nuance. From the standard biochemical perspective, the anesthetics already have clear classical mechanisms. They enhance inhibitory receptors like GABA and modulate ion channels and disrupt large scale communication patterns in the brain. So all of that is enough to explain people losing consciousness without having to invoke the quantum stuff, for example. So it's true that the anesthetics bind to tubulin and can affect the microtubule behavior. So that fits nicely with the OR's story, but it doesn't force us to accept it. So the same binding might simply be altering the physical stability or transport the functions in neurons in a purely classical way. So for this to be strong evidence, specifically for a quantum mind, we would need to show three things clearly. The first one would be that there is a measurable quantum coherence in microtubules or neurons. So the second one is that that anesthetics specifically disrupt that coherence, and the third one is that this disruption lines up tightly with the timing of loss and return of consciousness. So right now we don't have that full chain. So I'd say anesthetics binding to tubulin is suggestive and compatible with a quantum basis, but by itself it's not proof. So that needs to be clear. It's like noticing that every time your phone crashes, the battery gets hot. So that tells you heat is involved, but you still need to figure out how. There could be several different mechanisms, not just one special exotic one for this scenario.
All of this is very confusing, but what terrifies me the most is the possibility of disappearance and interruption of consciousness, because I can imagine what happened after we die. Is the same process of anesthetics or not? We can't know in fact what happened. But
That is one
Gerd,
million
do you want
questions.
to? Yes, the 1 million question. Gerd, do you want to make some observation about the question?
I want to make a question. Andrew, in your opinion and in your studies, do you think that one day we could describe the consciousness by by a mathematical formula. And what is, in your opinion, the ethical consequences to describe consciousness in by numbers? Do you
Yeah,
understand?
that's also that's also a good question. So let's talk about the ethicals on that, and of course the mathematical involved. I believe that every system, everything can be written mathematically. So we can use physics and mathematics to write everything. But there's like a trap because, for example, if you ask me how to calculate the planets that are orbiting the sun, I can say, well, we can use mathematics to explain that, how it works, but we don't know why it works that way. So we know how things are, how things, one thing complements other ones, but we don't know why. So we can reach a point where we are going, and I believe that it will be possible to explain the consciousness mathematically. We will be able to go to that direction, and I don't know if it will be in the near future, for example in 5, 10, 20 years, maybe
Yes.
later, but it will be possible. And talking about the other question that we mentioned, I believe that uh, we need to have not a regulation about how to measure that, because people are different one from another. So the conscious from one person is different from the other one. We don't know if the conscious are entangled all together or not. We are going to that direction to try to explain that, try to understand. But this is, and yet this is a very, how can I say that? This is not, this is complex, and we need to take these questions seriously but carefully as well.
Mm.
I don't know if I answered your question.
The last question is about the ethical consequences.
Yeah, yeah, the ethical part. Yeah.
Yes.
Mhm. Yeah,
But,
I believe that when we talk about the consciousness,
yes.
we are entering a place where, for example, how can I measure the it involves also a lot of things related to medicine. For example,
Yes.
when someone is about to die, and when this person lose the conscious, uh, how can we know that this person, we have a set of tests to do to see that
Okay.
and to identify that that person lose the consciousness, but how can we prove that? So
Yes.
mathematically with single tests. So this can be a question. This can also be a 1 million question. And talking about ethical is something that needs to be carefully structured, and we are going to be able uh, to create things that when you decide something ethically, it's very difficult to come back from that decision. So you need to be careful when you talk about these kind of things.
Yes, because it's very it's based in the line between ethicals and non-ethical. Even even in artificial intelligence, there are many issues about ethical parts. So here we are. Flavia, do you have any questions?
We have two more, but before we move on, I just want to say hello to my friend Oscar Ferreira from Argentina. He's watching us right now. So, hola Oscar, ¿qué tal? Me encanta que estés viendo nosotros. Me gustaría mucho saber si le gusta la física de la conciencia. Después hablamos. So the fourth question is, among the major theories of consciousness presented, global workspace space theory, integrated information theory, and Orch-OR, which currently appears closest to offering experimentally testable predictions.
Yes, the out of those three that I have mentioned, the global workspace theory is currently the most testable and the most actively tested, if I can say this way. And let's try to explain why. So the global workspace theory basically says that something is conscious when it's a broadcast across a wide network in the brain, so that many specialized areas like perception, memory, language, and decision making, and all get access to it at once, and that leads to clear predictions. For example, the conscious perception should be associated with widespread activity involving the frontal and the parietal regions, not just early sensory areas, for example. And non-conscious processing, like a word flashed too quickly to consciously see, should mostly stay local in the early sensory areas. And people have tested these ideas using things like masked stimuli. This shows something so briefly that the person says they saw nothing, but the brain still shows local activity in sensory cortex, but doesn't show the broader, the global ignition that GWT predicts for conscious perception. And also the binocular rivalry. So each eye sees a different image, and the conscious imagine flips back and forth. So the one that a person reports seeing is the one that shows the global network activation. And this is very interesting because integrated information theory is very rich conceptually. And it says the consciousness is about how much information a system integrates. So it's phi, and there are some rough experimental information, or I mean, there are some rough experimental proxies, and like the perturbational complexity index, which correlates with conscious state versus deep sleep or anesthesia. But the computing through phi is a real brain in practically impossible right now. So the theory is harder to test sharply. And the Orch-OR is even harder to test in practice because it depends on measuring quantum processes inside microtubules in living brains. And here we have also this ethical question: how can we enter someone's brain to measure something in the microtubules? So the technology to do that, we are still developing it, and some things we're technically far from being able to do right now. And so it's uh, in terms of which one can I actually test in a lab today. For example, with EEG or fMRI, etc. The GWT is clearly ahead. So uh, YYT is testable only in a looser, more approximate way, and the Orch-OR, I can say that is the least experimentally realized so far. Yeah.
So thank you, Adriel. I just realized that you are still sharing your screen, and Oscar Ferreira asked in the chat that what is that? The
Mhm.
mountains if we are in Mars right now. The
Sorry.
presentation, yes.
Yes,
So
I
yes.
it's
laughed a lot. Yeah. Um,
let's
so
stop sharing
if you
here.
want, yes, please stop sharing. So the last question we have here.
Mhm.
If future research confirms some form of functional quantum coherence in neurons, what would be the philosophical and scientific implications for understanding of consciousness, free will, and even the nature of reality itself?
Oh,
That's a tough question there. Uh, yeah. Uh, if we eventually show that neurons genuinely rely on quantum coherence in a way that matters for how they process information, so not just tiny background effects, but functionally crucial ones, that would be a big uh, paradigm shift. So on consciousness, for example, it would mean that our current classical models of the brain are incomplete. Uh, we need a quantum neuroscience that threads brain processes partially like quantum information processing, and we need to have that technology to do that, to understand that. It would give more credibility to theories like Orch-OR, or more broadly, theories that link consciousness to specifically quantum features of the world. On free will, for example, the quantum coherence, uh, it brings in real indeterminacy, events that aren't fully determined by prior classical tests or classical states, and that would undercut strict classical determinism. So some people would argue that this opens a space for genuine free will, where the brain processes can amplify quantum events into microscopic choices. But we'd still have to be careful. So randomness isn't the
yes.
same as freedom. The real philosophical work would be explaining how these quantum processes are shaped or constrained by reasons, values, and long-term goals. So things we intuitively associated with the free will. And talking about the nature of the reality, as you have mentioned, it would tighten the link between minds and the quantum fabric of the universe. some interpretations might lean towards views where consciousness is more fundamental than we currently assume, or at least not just an accidental byproduct. So it could influence how we think about the measurement problem in quantum mechanics, the role observers play in collapsing wave functions, for example. And if you talk about, if you talk scientifically and technologically, for example, we'd likely see a new field combining quantum tech with brain interface, as for example, we see Elon Musk doing things like that, perhaps leading to new kinds of anesthetics, psychiatric treatments, or brain-computer interface based on quantum principles. So it would also influence how we think about building truly conscious machines, not mechanics, machines. So we might need quantum level architecture, not just classical computation. So in a nutshell, confirming the functional quantum coherence in neurons wouldn't instantly solve consciousness or free will, but it will change the rules of the game and force us to rewrite both the neuroscience and parts of the philosophy from a deeper quantum informed perspective. That's what I think about this topic.
Oh, Adriel, congratulations on your excellent presentation. It's a pleasure to have a so distinguished guest like you, and me and Gerd. We need to invite more people like you to make to improve the FreeAstroScience channel with so impressive knowledge about physics of consciousness. This topic is really impressive and terrific, and as I said before, the state of the art today around the world. So I would spend all night discussing with you about this topic, about free will, about anesthetics, about the interruption of consciousness, about everything. But I know you are a very busy person and you can't stay with us for all the night. So, Gerd, do you want to make a last question, or do you want to finish?
I want to sincerely and deeply with Adriel to accept our invitation. And thank you so much, Adriel, because your field is very, very complex. It's very interesting. It's very innovative, and it is very ethical in the science point of view. So thanks so much, and keep research. Keep if you want in the future, we can organize another live for new updates in your field, in your research, and but for tonight, in name of the free artifacts, we are proud to use that you joined us. Thank you so much, Adriel.
It was my pleasure, Gert, and it's very good to see that we have people that truly believe in science and are trying to spread the science around the world with your channel and your free astroscience channel. So that's something very very important nowadays, where people are trying to are losing their sometimes losing their minds. They don't want to study. They don't want to talk about interesting things. So it was a pleasure for me to be here with you, and thanks for having me.
I, I, I hope one day to move on from this was to real to real classes, to real conferences. I, I, I really, I really hope to move on physically. So, for today, thank you to all of you, to my dearest Vice President Flavian. Thank you so much. And thank you all the viewers that tonight stayed with us. So, see you on the next time. If you want to see the video again, you can check on YouTube too. I will publish this video even to YouTube, also to YouTube. So, thank you so much. Bye bye.